This video is all about classifying matter, and what we do with classifying is sort of be able to sort different materials out into different categories and then study them based on the category that they're in. We handle elements differently than compounds, we handle mixtures differently than substances, and so on. This will help you to know which category a particular material that you're studying falls into. First, a quick review. First, remember from previous knowledge of previous notes or other classes that matter is anything that has mass or volume. So that includes all solids, liquids, and gases. That's important because as we start to classify matter, we have to know what's matter and what's not. What's not matter? Light, energy, heat. Those aren't matter. Those are energy. So basically you can categorize everything in the real world into matter or energy, and generally we're going to be studying matter most in chemistry. The stuff we're classifying here is matter only. So things like light aren't matter. Things like UV rays aren't matter. Things like radio waves aren't matter. Heat isn't matter. Now matter can release heat, matter can release light, but the light and heat are not matter. A phase, new term perhaps, a phase is a region of matter that has its own unique properties. A part of a material that you can visibly tell from the others or be able to observe is different from the others. So a phase is a part of a material that you can see is distinctly its own. It has its own color, it has its own state, and so forth. And you'll see some examples of that coming up. An interface is the place where two phases are in contact with each other. So for example, where your fingers might be right now holding your phone or touching your keyboard, that's an interface because it's the place where your finger meets the keyboard. At that point is where changes in matter can occur. So if we start to look at where you leave a fingerprint, well, you only leave a fingerprint where you interface with your surroundings, where you touch a surface. Melting can only happen where two phases are in contact with each other. Boiling can only happen where two phases are in contact with each other. And reactions, too, only happen where two phases touch, and those are at interfaces. It's not interphase. That's a cycle or a part of the cell division cycle in biology. This is interface. As if you're using the word surface, this is an interface. So in this picture you can see that we've got a clear liquid phase. The liquid at the lower part of the test tube is clear, and into that has been added another liquid, and that's causing the result here that we see as a solid yellow precipitate, or that yellow solid that's kind of swirling through the test tube. So we have two phases visible here, a clear liquid phase and a solid yellow phase. Where those two touch, everywhere you can see along the edge where the boundaries are of those things, that would be the interface between those two phases. So that's just going to help you to clarify a little bit about what an interface means. If we look at an upside down blizzard here, which looks delicious at the moment, what kind of phases can we see? Well, you might recognize there's an ice cream phase there. You might recognize there's a graham cracker phase. There's a candy phase. And if we look close enough at that, we can see there are two phases within that. There's a chocolate layer, and then in the inside there's a marshmallow layer. So we're looking at a s'more blizzard here. Lots of different phases. And if we look at a glass of Coke, we can look at places where we start to see those changes that I mentioned happening at the interfaces. So for example, melting is only happening where the ice cubes meet the liquid. Ice cubes only melt on their outside edge. And condensation, I don't know if you can see it here, but there's little droplets of water on the outside of this glass. That's only happening where the cool glass is meeting the air around it and causing moisture from the air to condense from gas to liquid state. So changes only happen where there are interfaces. And here's one more example that you've seen, I think, in previous videos or in previous notes in class. Alka-Seltzer tablets dropping into water. The only place they bubble is on their edges. We can only see the new gas, carbon dioxide here, being formed where the tablets are touching the water. They don't form bubbles everywhere else. You can see lots of blue area around the tablets where nothing's happening. And if we could look inside the tablet, nothing's happening there. As it gets smaller and smaller, the reaction's always happening at the surface. So as we start looking into classifying matter, what I'd like you to do on a blank sheet of paper here is draw out a little flow chart that looks kind of like this one. Several boxes kind of stacked all together. And I would try to make this as big as you can. If you can designate a whole page in your notes to it, you'd be better off. Because you're going to have a few things to write into each box. And if you can spread them out, it's a lot easier to read it and keep track of things if it's not so crowded and crunched. So we've got a starting place at the top in a black box here, and then it splits up into two, and then each of those splits up into two. The colors aren't necessarily important that you emulate those in your notes, but you can if you'd like, because the red side and the green side are distinctly different things. In that first box at the top is material, and material is just a very generic term for any kind of matter that we can give a name to. So materials are any number of things. Here's 4 examples of material. We've got a bar of gold up at the top, we've got a glass of Kool-Aid in the bottom left, we've got a little flask of Italian salad dressing at the bottom, and then there's some crystals of salt at the top right. So those are different materials. So materials are any specific kind of matter. Those would all four be different kinds of materials. Now you might be looking at the glass of Kool-Aid and saying, well, there's actually ice in there. That's a different material. You're right, it is. And heck, the glass is its own material too. Same thing can be said of the Italian salad dressing. There's a container. There's kind of a yellowish green layer in there. There's little bits of herbs or whatever the heck is in there. So there's all kinds of different phases within that, but we would call that as a whole Italian salad dressing. We would call that Kool-Aid. The first subdivision then is called a substance. The substances are materials that have definite composition. And by definite composition we mean we call them by the same thing and they have exactly the same makeup everywhere and anywhere you go. If I call it by that name and you call it by that name, we're talking about exactly the same thing. Substances, things with definite composition, include things like gold. 24 karat gold bars like you see up in the top there are the same kind of gold all the way through. There's nothing else there. And sodium chloride is sodium chloride no matter where you go. If I have a bar of gold and my friend over in China has a bar of gold and my friend over in France has a bar of gold, they're all exactly the same. And the same thing with sodium chloride. If I have a bottle of that in my shelf and there's a chemist who's over in Germany that has a bottle or a chemist who's in Nigeria that has a bottle, it's all sodium chloride no matter where you go. Everybody calls it by that same name. And if I say sodium chloride, chemists know exactly what I mean. That makes it a definite composition. That makes it a substance. There are a lot of things that aren't substances that we use in chemistry as well, but those are substances. The opposite sort of thing there is mixtures. Instead of a definite composition, mixtures have a variable composition. And variable just means that it's different from place to place. You might call it by the same name because it's a material, so it has a name. But from place to place, it can be very different and still be called that same thing. And so from our examples, mixtures with materials rather with a variable composition would include something like Italian salad dressing and Kool-Aid. They're very different from place to place and over time. If I have Italian salad dressing and I go across town and buy a bottle from a different store, it's not necessarily going to be exactly the same thing as what I have, but both bottles would be labeled as Italian salad dressing. And Kool-Aid from place to place can be mixed at different concentrations or even mixed at different flavors and still be called Kool-Aid. So a name that doesn't necessarily specify a very specific thing means you're talking about a mixture. Of the substances, we break those up into two categories. The first is our elements. Elements are those substances that have only one kind of atom in them. One kind of atom. There are about 90 of these that naturally occur on Earth, plus about another 30 or so synthetic elements that have been made by people in labs over the years. These are listed on our periodic table. It's a rather short list, and if one was so inclined, you could memorize the periodic table. You can't memorize compounds, you can't memorize any of the mixtures. The rest of that is basically infinite or practically impossible to memorize. But an elements list is pretty short. All elements have one phase to them, and the word homogeneous shows up here for the first time. You'll be hearing more on that term later, but these are homogeneous. Elements include things like gold, and when we say that they have only one kind of atom, we mean that they all have the same atomic number. You know on the periodic table that gold's atomic number is 79. That means that every atom of gold in that bar has 79 protons in it. That means one kind of atom only. Now this bar is labeled as 99.99% pure, so there's a little bit of something else in there, but for our purposes we're going to say that that's pure gold and every atom in there has 79 protons. That means it's an element. On the other side of that division is a compound. A compound is a material, yes. It's a substance, yes. And even more specifically, it's a compound. A compound has two or more kinds of atoms in a constant ratio. And that ratio is really important. There are millions of these, but all of them are homogeneous, which is to say they have one phase only and no interfaces. So compounds are things like sodium chloride. Sodium chloride is one sodium ion for every chloride ion, 1-to-1 ratio forever and ever, everywhere you go. Water, for example, H2O, is a 2-to-1 ratio, no matter where you go. That's what water is going to be. And so that makes it a substance because it's the same everywhere, and it's a compound because it has a ratio of two kinds of elements put together. Compounds can have anywhere from 2 to dozens of different elements put all together. Most compounds we'll study have anywhere from 2 to maybe 5 or 6 most of the time, but they're always in a whole number ratio that you can write a formula for and write a name for. Homogeneous mixtures are those mixtures that have one phase. They're the same all the way through, but they have different composition from place to place. So a mixture has a variable composition. A homogeneous mixture has only one phase. And here we're talking about the Kool-Aid in the glass. So Kool-Aid, as mentioned, can be stronger here and weaker there and more watered down over there. And maybe here we're talking about a cherry Kool-Aid and there we're talking about orange Kool-Aid. They're all Kool-Aid. They vary from place to place, but they're homogeneous because there's one phase. If you look at Kool-Aid, you don't see floating bits of pulp. You don't see little bits of sugar that aren't dissolved. If you've stirred it up really well, you don't see other things in the Kool-Aid like you might in Italian salad dressing. So homogeneous mixtures means you have one phase and that it's uniform all the way through. If we take that Kool-Aid and let it water down for a while as the ice cubes melt, it might start looking pretty pale. It would still be called Kool-Aid. You might not want to drink it, but heck, it's still called Kool-Aid because it's still got the same stuff dissolved into it. It's just become watered down. And a heterogeneous mixture is a mixture that has at least two phases and often many more than that. Multiple phases means it's heterogeneous, different origins, different parts. And a heterogeneous mixture from our example is Italian salad dressing. If you look at that, there's layers in there, there's bits in there, there's herbs in there that float. You can visibly tell that they're different. They are their own phase. There's an oil phase, there's a vinegar phase, there's an oregano phase. I don't know what they put in there, but all kinds of different stuff. And no two Italian salad dressings across the world might be the same. The stuff you get at Olive Garden is different from the stuff you get at Carino's. That's different from the stuff you buy from Kraft. That's different from the stuff you buy from Hidden Valley in the grocery store. And they're all called Italian salad dressings. One name, many, many different compositions. So there's our finished chart, and we'll add a little bit more on it with the terms of heterogeneous and homogeneous when we get back together in class. If you need to rewind and pause on some stuff, I'd highly encourage you to do that. In the meantime, get those notes down and this little flowchart drawn, and we'll take it from there with our next couple labs.